All right. In this lesson, we're going to be looking at the unit circle. The unit circle has its center at the origin of the rectangular coordinate plane or coordinate system. The radius for the unit circle is 1. So if we take a look at this right triangle, it has the radius is 1, so the hypotenuse of this right triangle is 1. Since the hypotenuse is 1, that tells us that cosine of that angle measure is just going to equal whatever the x-coordinate of that point is on the unit circle. And the y-coordinate for each one of the points on that unit circle is going to equal the sine of that angle measure. Since sine of the angle measure is going to equal x, and cosine of the angle measure equals, sine of the angle measure equals y, and cosine of the angle measure equals x, then tangent is going to equal y over x. Cosecant is the inverse of sine, so it's going to be 1 over y. Secant is the inverse of cosine, so it's going to be 1 over x. And cotangent is the inverse of tangent, so it's going to be x over y. All right, for these two special right triangles, we want to determine what the measure of the other two sides will be, given that the hypotenuse is 1. So for the 45, 90 degree triangle, if the hypotenuse is 1, we set 1 equal to the length of the leg times the square root of 2, and determine that the length of each one of the legs will be 1 over root 2, or once we rationalize the denominator, root 2 over 2. For the 30, 60, 90 triangle, if the hypotenuse is 1, then the short leg, the side opposite the 30 degree angle, is going to be equal to, the hypotenuse is equal to the short leg times 2. So the short leg is going to be equal to 1/2. And the long leg is always the length of the short leg times the square root of 3. So the long leg would be 1/2 times the square root of 3, or root 3 over 2. All right, if we take a look at this figure here, start with 0. The x-coordinate of that point is positive 1, since the radius of the circle is 1. And the y-coordinate is 0, since it's on the x-axis. Moving on to the 30 degree angle, if we drew a line straight down to the x-axis, we get a 30, 60, 90 degree triangle. And we just determined on the previous slide that the short leg, if the hypotenuse is 1, the short leg is 1/2, and the long leg would be the square root of 3 over 2. So the x-coordinate of that point would be root 3 over 2. Y-coordinate would be 1/2. For the 45 degree angle, if we draw a line straight down, we get a 45, 45, 90 degree triangle. And we determined on the previous slide that both legs of 45, 45, 90 degree triangle are root 2 over 2 if the hypotenuse is 1. So the x and y coordinates for that point are both root 2 over 2. For a 60 degree angle, we're just going to flip-flop the x and y coordinates for the 30 degree angle. All right, so for the x-coordinate at that 60 degree angle, the x-coordinate is going to be 1/2, and the y-coordinate is going to be root 3 over 2. And then for the 90 degree angle, the x-coordinate is 0, and the y-coordinate is just going to be positive 1, again, since the radius of the circle is 1. And this pattern repeats itself in all 4 quadrants on the coordinate plane as you move around the unit circle. The only thing that changes is the sign for each one of these coordinates. So for quadrant 2, all the x-coordinates are negative, all the y-coordinates are positive. In quadrant 3, all the x-coordinates are still negative, all the y-coordinates are negative. And in the 4th quadrant, all the x-coordinates are positive, and all the y-coordinates are negative. So you're still going to have the same x and y coordinates. Only thing that's going to change in the different quadrants are the signs. So if we want to find out what the cosine of negative 180 is, we should probably draw a figure The terminal side of that angle measure would point to that point on the unit circle on the negative x-axis. The x-coordinate of that point is -1, y-coordinate is 0. And cosine of the angle measure is going to equal the x-coordinate of that point, which is -1. So cosine of -180 is just going to equal -1. For this example, we want to find the secant of 90. So if we draw the terminal side of that angle, it's going to point to that position on the unit circle. The x-coordinate of that point is 0, and the y-coordinate of that point is +1. Since secant is the inverse of cosine, and cosine is equal to the x-coordinate, x-coordinate being 0, we would have 1 over 0, which is undefined. You cannot divide by 0. And now we want to find the 6 trig ratios for a 135-degree angle. Start by drawing the angle, and you can see that that angle measures, that terminal side is going to be in the second quadrant. If we draw a line straight down, we get a 45, 90-degree angle. All right, again, the hypotenuse is 1, so we know that both of the legs of that 45, 90-degree triangle is going to be √2/2. And so now we can determine what all 6 trig ratios are. All right, so sine is the x-coordinate, which is negative. Sine is the y-coordinate, which is √2/2. Cosine is the x-coordinate of that point, -√2/2. Tangent is sine over cosine. Since those two are just reciprocals of each other, when I divide one by the other, I'm just going to get, they're not reciprocals of each other. They're the same thing, so if I divide one by the other, it's just going to get -1. And then cosecant is the inverse of sine, so if I flip square root of 2/2, if I take the reciprocal of that, I get 2/√2, which once I rationalize the denominator will give me √2. Secant is the inverse of cosine, so the reciprocal of -√2/2 is just -√2. And then cotangent is the inverse of tangent. Inverse of -1 is still -1.